I'll be focusing on relative dating, which is determining a chronological order of rock layers. There are two types of dating methods, relative and absolute. We are working with relative, which deals with chronological order, while absolute gives rock layers specific ages and time periods. With relative dating, we are also looking primarily at sedimentary layers, just based on how they deposit over time and the methods that we use to then layer these rock sequences in order. So surveyor William Smith in the 1800s noticed that there was a distinguishable order of rock layers. These layers are called strata. He also saw that there were specific fossils that delineated specific rock layers. What he then did was map all of England to show the time frame of the animals preserved in the rocks, which then helped to understand the sequence of rock layers. William Smith's recognition of an order in which rocks had been formed in England based on the sequence of strata is called stratigraphy. Geologists are still using this as one of the primary methods of relative dating. Through his research, William Smith set forward the beginning of stratigraphy as a method of relative dating. So stratigraphic dating is organized into time rock units, which means they rely on the study of two sequences, a time scale and the scale of rock sequences. It's not important knowing the distinction of each of them because they are commonly lumped together as time rock units. So stratigraphy is based on the previous knowledge of how rocks are formed. When William Smith identified sedimentary rock layers and their ages based on chronology, the levels of rocks were undisturbed by the forces in the earth. Looking at Steno's laws will help us to understand the sequencing of layers if they have been subject to movement. So stratigraphy is only useful if the layers are deposited horizontally and have not been changed. Steno's laws established relative relationships in strata and how they change over time or when they are forced to change because of sequences in the earth. The first law is the law of superposition, which states that younger layers of rock are above older layers of rock, and this is what William Smith used. The second law is the law of original horizontality. This states that sedimentary rock layers are always deposited horizontally and parallel to each other. If their orientation changes, then that means that there was tilting or folding or faulting after those sedimentary rock layers were deposited. The third law is the law of cross-cutting relationships, which states that rock layers are older than the intrusion that disturbs them. This intrusion is called a dike, and they are usually igneous and are happening because of plate tectonic movements. The fourth law is the law of lateral continuity. This states that all layers of rock are continuous until they encounter bodies of water that block them, or if they undergo changes after they had formed. This helps us to link opposite bodies of a river, or in cases like the Grand Canyon. It gives us an idea of what happened when these bodies were forming or after they were formed. So Steno's laws help us to understand how sedimentary rock layers can be changed over time based on how they interact with Earth's forces and the environment around them. Knowing these four laws, we can begin to understand how complex strata can be chronologically ordered. What can also help are other methods of dating fossil-bearing layers, the first being faunal succession. This is what William Smith used. It states that fossils that are included in the strata give the rock a definitive pattern. This is mostly useful when we're trying to date things in chronological order and they are far apart. So on different continents there will be the same layers of fossils because on the geologic timescale, certain eras include specific types of animals that were alive in that era. So if you see things, if you see the same fossils, based in different strata across the world. That means that they were probably deposited at the same time. The second method is the cross-cutting relationships. I'm stating this again, even though we saw it in the past slide, because it also includes inclusions. So this method states that sedimentary layers are older than the dike igneous rocks that cut through them. This relationship also deals with inclusions. So inclusions can happen in either sedimentary or igneous rock formations, but what is the same is that these inclusions are always older than the rocks that contain them. So in this image, you can see both sedimentary and igneous rock inclusions. So the first sedimentary rock inclusions are called clasts, and they usually occur because the top layer is eroded over time, which means that there are loose pebbles or just like pieces of the sedimentary rock that are loose and then are in the next layer of deposition. In igneous inclusions, these happen when the igneous intrusion brings up some of the parent rock and then aligns it with the strata when the magma cools. So these inclusions are called xenoliths because they're igneous. But what it is part of the parent rock that is lifted with the magma and then displaced when the magma cools. These xenoliths are reconstituted from the parent rock because of something called contact metamorphism, which is when the heat and the fluids in the intrusion cause chemical changes in the parent rock. Another method that we can use is including diagnostic artifacts. So these are objects that have an approximate age that we can start to trace in historical records and give the strata and age. So these include things like bodies, jewelry, pottery, weaponry, anything that is included in a historical record that will give the strata a relative age. So now I will test how well you understand relative dating. In this image, you can see several layers of strata, and I will ask you to organize them from oldest to youngest. So pause the video now and organize them accordingly. So D and A are the oldest and the second oldest, based on the law of superposition and also the law of horizontality, which tells us that because D is below A, then it's older than A. And because they are at a different orientation, they have been tilted after they were deposited. So the next youngest is E. Because of the law of cross-cutting and because it only goes as far as layers D and A, we know that it is the second youngest, which means B is the next youngest because it is on top of E. And then C is the youngest because it cuts through all of the 4 layers.